Everyone talks about the weather, but nobody does anything about it. So what can we do in this to address this really major issue? When I started thinking about this talk, which was around the beginning of May, it was a very appropriate time. There had just appeared in Nature an editorial that was essentially urging governments of the world to take action with regard to climate change. They suggested that now is the time to act. Perhaps we've already passed some critical points to act, but nonetheless, late is better than never. And another point, that this is a really old cartoon, some people may recognize it, is that we're responsible for major changes to the Earth's system. And the concept that humans contribute to environmental degradation is not at all new. What's new is really the scale of it, that where our actions are having impact on a global scale. We've always recognized that we could have impacts on local scales. This is the famous Pogo cartoon, we have met the enemy and he is us, referring to a very localized kind of environmental degradation. And in the past, we've thought about environmental degradation as local and also the solutions as local, and now we have a different scale that we have to address. So what should we do? I'd like to address this in 4 different levels. All of us here are citizens of one country or another, very many countries represented in this room, and we can participate in processes as citizens. We're also consumers, all of us here, as individuals, where our habits, our traits, we've heard a little bit about this already, influence enormously the consumption of energy and resources. All of us are scientists, or most of us in the room are scientists, and certainly we have an interest in bringing our science to bear on this very important problem. Eric has encouraged us to do that. And then within science as a general area of activity, we're specialists. I was going to write geochemists, but of course there are many other disciplines represented here. And the question is, how can we bring our specialties to bear on this problem? I'd like to just comment here that I have issue this little disclaimer that my positions here are my own personal opinion, certainly do not represent the official position of the Swiss Confederation and even EAWAG. So I think now that we have a change in the way that people have to think about our interactions with the global planetary system, and it's not the first time in history that we've had to make major changes in our perception of how we as a species fit into the cosmos. There was a pretty harsh realization back in the 1600s that we were not the center of the universe, that the sun went around the Earth and not vice versa. We had another big blow in the 1800s with Darwin's theory of evolution, that we are descended from apes and very closely related to our primate cousins. Of course, that hasn't been completely accepted in my home country. But now, in 2000, Paul Crutzen articulated this concept of the Anthropocene, that is a period now within sort of geological history of the Earth where human activities are one of the major drivers on a planetary basis. And we've seen some of these types of slides already with population and also with different types of activities, for example, or processes, the denudation rate, here the anthropogenic denudation rate related to baseline, that we have this major impact on the climate, on the planetary system, and because of that, we have to rethink what our responsibilities are and how we're going to essentially interact with the planet. So what are the implications of living in the Anthropocene? I think we could all do worse than to dig all of those buttons from the 60s and 70s out of the closet, maybe not all of them. But certainly these other two, think globally, act locally, and if you're not part of the solution, you're part of the problem. These are very relevant to today's issues. And so what I'd like to do then is to go to those points of what we can do at different levels. But before I do that, I'd just like to reiterate something we heard from the other speakers, and that is that the challenges we face really are immense. They're immense because we're dealing with this issue before population is stabilized, as we already heard. I won't belabor that. We've also seen that and probably know from our own experience that patterns of consumption change with increasing development, and here we just have those consumption patterns reflected in the food consumption. And the issue there, as we already heard from Goldschmidt, is that the diet and consumption patterns that are more typical of the developed countries are more energy and resource intensive. And as countries develop and the diet shifts, for example, from cereal products to more food, dairy and meat, then we see different types of pressure on the natural resources and energy balance. We've also heard that there are huge inequities across the planet in terms of resource allocation. There's a series of these different maps that are available on the web that show essentially continental size scaled to various types of consumption. Here it's shown for fuel use, but it shows up in many other indicators as well. And there is this truly massive inequity of resources being used in different parts of the world, and certainly this is not something that's sustainable over the long run. So we have these immense challenges. What are we going to do? The first level, I just mentioned very briefly what we could do as citizens, and here the first thing is participate, right? Not to sit back and sort of watch the show from the sidelines. And one thing I'd like to mention specifically, we heard this earlier, was in this supporting the efforts to address climate change at local, regional, and national levels, I think it's important to think a little bit outside the box. And one of the issues there is supporting the education and rights of women. This is one of the Millennium Development Goals. There are a lot of issues, for example, with school attendance, especially in rural areas of developing countries, of girls and boys. And if we want people to be able to change their practices, to be able to change the allocation of resources and the economics, then women are a big part of that equation. And so even though this seems very distinct from the climate change issue, I would argue that it is in fact very intimately connected. What about consumers? This is one of the many, there's about a bazillion of them, carbon footprint calculators that you can find on the web. I didn't actually run this for myself. I did one time when I was teaching a course at Caltech, an Introduction to Environmental Engineering, and it was really kind of depressing because I thought I was a pretty good citizen. I biked to work, you know, I didn't hardly drive at all, which is unusual in Southern California. And the big place that my footprint showed up was in my air flight. And I could not even maintain my premier status on United, right? And so I'm not saying here don't fly. I mean, that would be hypocritical. But if you think about bundling trips together once a year, right? If you think about once a year not flying and doing something by high-speed video conferencing, if you think about one conference where when it comes to the time of the conference, you think, what was I thinking when I said yes to this? You could call them up and say, well, I've decided to reduce my carbon footprint, so I have to flake out on your meeting. I did that once. Though I should say before the fact, not after the fact. But these are things that really we should be thinking about. What about what we can do as scientists? This is perhaps something particularly for the Americans in the audience. I think scientific literacy is a huge issue in the United States, and we have really a serious sort of public policy issue in the fact that we're not having a scientifically literate voting public. Supporting outreach, I think, especially on issues related to climate change, is an important thing. We need to recognize that some of our colleagues will be engaged in outreach activities, and some of them are really very, very good at it. And we should support them in that. And we shouldn't undercut them. We shouldn't say, oh, they need to be doing more of this and not that much of the outreach activities. And so we have to recognize this takes a lot of time, it takes a lot of skills. The people who are doing it deserve our support. We should also perhaps consider participating in outreach, but if you want to do it, please do it right. There are some skill sets that you can learn, and there are a lot of different organizations that are very willing to help people learn those skill sets, but it's important to communicate well, not as Bill Chimides mentioned, to make your audience feel stupid and go home with the idea that there's nothing that they're going to be able to understand about the issue. I also think we have a lot to learn from the IPCC. I think they've really handled things in a very, very interesting way with regard to communicating some very complex issues to the public, and particularly in this area of uncertainty, where I think a lot of scientists get very hung up. We are not comfortable talking about issues because we don't know how to communicate the uncertainty, and if we leave it out, we feel that that's just so inappropriate that we can't do it. And there are two things I'd like to mention about how the IPCC did this, which I think are very valuable in many contexts. One is to be able to identify for a particular issue or information that you're trying to get across, what is the level of evidence that supports it, and what's the level of consensus or agreement among the scientific community. Another is to have some way to calibrate the level of confidence between or along this range of statements where there's very high confidence to statements where there's much less confidence, and really to focus the public discussion on the topics or the issues where we do have that strong consensus within the scientific community. That's not what we do with each other. When we go out into the different sessions, we talk about this stuff, where there's low confidence, where there's low agreement, because that's the interesting part. That's the part where science moves forward. But in terms of engagement outside the scientific community, that's not what people need to know, and it's not what they're interested in. And so we need to be able to focus on the areas where there is consensus so that we can make some fairly significant statements about it. So what should we do as specialists? I think probably everybody has seen these wedge diagrams. This is the original version published in 2004, and so I include it for that sort of historical purpose, but it's not a very attractive figure. But the concept is that we have fossil fuel emissions, and then we have these variety of different types of approaches that can be taken to stabilize this stabilization triangle, to stabilize the situation so that we don't have increased emissions from fossil fuels. This other one I kind of like because it blows up the triangle, it's colorful, and it starts listing some of these different contributions to the overall problem. And the point here is that there's not going to be a single answer to a problem that is very deeply embedded in our very basic way of life. There's not going to be one answer, and we shouldn't worry about one answer. We should worry about finding a multitude of approaches that we can bring to bear on this problem, and I should point out that that some of these are going to be indirect. From the first, on the surface of it, it will look like you're not talking about anything to do with energy. But sometimes if you look a little deeper under the surface, you'll see that there is a contribution to this issue. So what I'd like to do now is to show you just two examples of work that started in very different directions. It did not look initially to have anything to do with energy, but in fact has some bearing on this situation. The first one was a problem or a situation, a study of methane in Lake Kivu, which is a lake in Africa that has a very, very interesting situation where there is a huge amount of methane stored in the deep water of this lake. And there were originally studies, well, studies even before this, but some studies initiated by Bernhard Verli from the ETH Zurich and ERWAG, a biogeochemist, and Johnny Wüst, an environmental physicist, and they were interested in this initially really from perspective of the natural sciences. What's going on with the methane? How much methane is escaping to the atmosphere? But at the same time, this is an enormous reserve of energy that's stored in this lake, and the local communities are very interested in exploiting this energy, and in fact this is now an operation to extract the methane for use as fuel, which has two advantages to it. One is that you're using this methane instead of a fossil fuel, and the second is that this methane could potentially escape to the atmosphere and then be itself a very powerful greenhouse gas. And so then Bernhard and Johnny are both now involved in some sense as expert consultants on some aspects of this extraction problem or extraction activity, and understanding then what are the implications of this for the cycles in the lake and so on. So that's one example. A second example has to do with nutrient recovery from human waste. This idea of source separation, particularly separating urine from feces and recovering the nutrients from the urine, is based on two things. First is that about 80% of the nutrients that are excreted by the human body are excreted in the urine, and urine is, to a first approximation, free of pathogens. There is no danger of spreading disease or anything like that. And you can also precipitate struvite, which is magnesium ammonium phosphate, relatively easily from urine. In fact, it precipitates pretty much all on its own, but you can give it a little bit of help by adding magnesium. This is a 50-liter reactor that was designed for local use by Kai Uter, who's an environmental engineer at ELVAG, and Elizabeth Tilley, who's a member of our Department for Water and Sanitation in Developing Countries. And there are two interesting aspects of this from the energy perspective. The first is, if you're not getting your phosphate from urine, which is a local source, then you're getting it from mining phosphate rock. And all sorts of resource extraction activities are in general energy intensive. The second thing, of course, is that once you mine that phosphate rock, you have to transport the fertilizer to where you're using it. If you're essentially recovering it locally, then you don't. Another issue is that once you precipitate the struvite, you have a waste liquor, or a residual liquor that's extremely rich in nitrogen and can be used in drip irrigation. Drip irrigation with untreated urine is a problem because the pipes clog, and the pipes clog because struvite is precipitating. You take the struvite out, and you have a very nitrogen-rich fertilizer that you can use directly. Fixing nitrogen is enormously energy intensive. And if we can avoid that, then we can conserve energy. So these are just a few examples. There are some other examples, as I mentioned, in the poster session tomorrow. I encourage everybody to come up with your own, your picture here, your work there, and think about these different ways to add things together. I'd also like to just mention that we could be creative here. All of us probably read Jules Verne when we were kids, and there were many ideas in there that predated the actual discovery and implementation of technologies. And we should seek opportunities within the crisis. It's perhaps a cliche to say that the character for crisis in Chinese contains the character for opportunity. This is something that Thomas Friedman pointed out in his recent book, and is also in a slightly older book, Cradle to Cradle. Again, not focused so much on energy, but more on resource conservation. But as Eric pointed out, these are not separate from one another. I'd also like to mention that there's a role for institutions. This is an example from ELVAG of something we call our zero energy building. It's not exactly zero energy, but essentially we have an office building for 150 working places that uses approximately the same energy as a one-family house. And I would invite everybody to look at our website there. I see Eric is standing up in the corner. So this is my last slide, the price of inaction. Right? Perhaps we're already going to pay the price of inaction regardless of what we start doing now. But certainly we don't want to find out what the real effects of a 2, 4, or even more degree warming on the planetary system would be. And there's many very dire consequences that have been laid out, potential consequences have been laid out by the IPCC. So the last comment I'd like to make before I close is simply that, and we've already heard this, the different types of securities of energy, of food, of water, of soil. Marty Goldhaber gave a very nice talk this morning about the issues with soil conservation and soil quality. And even economy and sort of territorial security, these are not separate from one another. And there's always a danger when you start, for example, putting a big emphasis on biofuels, which has happened in the United States, that, ba-choom, surprise, surprise, the price of food goes up, and farmers are really in trouble, or actually some of the farmers are in good shape, but the people eating the food are in trouble. You can't just pull on one part of the system without paying attention to the others. It has been described biofuels as a way to turn water into oil. and we need to think about all those parts of the system together. But I would encourage everybody to, as Eric suggested, put your creativity and your talents to work to addressing this problem. Everyone will have a slightly different take on it and contribute in a different way, but I think we all have something to contribute. Thank you very much.